I'm going to hand you over. I'm going to hand you over now to Dave Carroll, Chief Fire Officer, Tipperary Fire and Rescue Service, to open the seminar.
Thanks, John. You can hear me okay, yeah?
Yeah.
Yeah, okay. Listen, thanks, John, and welcome everybody. I'd normally say welcome to Tipperary or welcome to wherever, but it's welcome to wherever you are in the wonderful world of Zoom. So this evening, really look, it just falls to me to welcome you to the seminar. It's something that Martin and John have pulled together. I suppose it aligns really with the fire service and with us as a building control authority as well. Really what we're about is fire safety, life safety, and technical guidance document B, volume 2. It's unique, I suppose. It's only there 4 or 5 years, but for the first time it really, domestic dwellings are exempt from fire safety certification, and for a long time we were beating the drum that really we needed to still focus on the domestic dwelling, because quite simply it's where we lose everybody in fires. With very few exceptions, those that die in fires die in the domestic setting, and most of those domestic settings are kind of individual houses, not flats or apartments. So it's where the focus, since the advent of building regs back in 92, 93, it has excluded that premises which contributes most to fire deaths in Ireland. So thankfully we now have a technical guidance document, which has gone in a long way, we think, to addressing that deficit. Thankfully, the level of fire deaths has come down enormously across the country. Where it was standing at an average of somewhere between 45 and 50 20 years ago, it's down into the teens now, which is incredible. And it's up there against the best in the developed world. It stands amongst the best fire deaths per head capita across the developed world. And that's in no small part to building regulations, to designers, to builders, to yourselves who are doing the job out on the ground in making the houses safe. So look, what Martin and John have pulled together in addition to tonight is a kind of a short guidance document, which is looking at some of the kind of construction details peculiar to the domestic setting, in particular, I suppose, the 3-story, the attic extension and stuff like that, and just some of the little bits around the enclosures of the stairways, the doors, stuff like that. Simple construction details, I suppose, but it's very general and broad in nature, the document. I think myself, it's a fantastic resource, but really the resource that you have here in Tipperary is Martin, John, and some of their colleagues, Ray O'Leary, Stephen Hegarty, and others. I'd urge you really to use them. If you have concerns, either as builders, designers, anybody involved in and it's not just for the domestic dwellings, but for anything, come to us and ask us. We're not, we hate to use the stick. It's not what we're about. We don't really use it. It's in exceptional circumstances that we kind of adopt the stick approach. We're much more much more interested in being collaborative, working with the designers, the builders, developers, just in getting it right. And it's a lot easier to get it right in advance of the construction bit at all. You don't get it right on paper. We're still only dealing with lines and ink and paper. So, that's the place to get it right. Should there be any kind of doubts or anything, I really would urge you to talk to Martin, John, any of us, drop a line to anybody, pick up the phone. We are approachable. Trust me, we are. That's what we're about. That's the commitment I give kind of tonight, and it's the commitment I give to my chief executive in Tipperary. That's the way we like to approach things, and we do it successfully across a lot of areas, and certainly on this one, I'd offer the same. So I'm not going to delay you. You have a busy. I was going to say a busy couple of hours, but I suspect you're not going to hold anybody for a couple of hours tonight. There, the discussion continues that way, which would be a good sign. So the best of luck. Thanks in particular, look to Martin and John and to Kate for pulling this together. It is really important and it is really valuable. Unfortunately, I can't stay because I'm going to another meeting. but I will be looking at the recording, and I have been through the documents and stuff, and I think I hope you find it useful, and any feedback that we can get, please offer it, because it's something I'm looking at this and thinking this should be happening nationally, you know. And if that's the case, well, we are the premier county, so let's lead, and we'll deliver that. And it's not easy to say that as a Cork man, but you know, I do have to say it now and again. So best of luck, and thanks again to John for hosting it. Okay, John, thank you.
Thanks, Dave. Okay, so just to get to the actual details of the presentation here tonight, it's in two parts. We'd hope to be finished in about 40 minutes or so in terms of the presentation, and leave some room for questions. So the first part really is around regulatory advice, and then some of the detailed technical build-ups that Martin will talk to in the second half of the presentation. So just before we actually get into the actual regulatory requirements, and it talks about what Dave mentioned there earlier, is that the construction sector, I'm not sure if you're aware, but there's a document published, I think, once a year looking at the construction sector. The last one was published in July 2022. And what's interesting is there's now 160,000 people working in the construction sector, but also that there's actually about 58,000 companies. So the average size of the company in the construction sector is 3 or 4 people. And those are small and medium enterprises right throughout the towns of Tipperary that are providing valuable local employment. They're also providing support in the local community in terms of sports clubs or other charitable organisations. And we want to work with you in the construction sector to enable the sector to thrive and prosper. And really, we see ourselves working together. We're on the same side. This is not an adversarial relationship, but a collaborative relationship as we go forward. A little bit of history in terms of regulation. There's nobody probably here online who actually would want to kind of talk regulations kind of as their favorite subject, but I suppose I've taken London as an example, all right? And in the 12th century, there was a major fire, and they banned thatch roofs within the city boundaries. Okay, 400 years later, in 1667, they had another big fire, and they banned timber construction within the actual city boundaries. All houses be built in stone and brick. By the 1860s or 1850s, they had typhoid and cholera outbreaks in London, okay, and they came forward with more regulations around sanitation and water supplies, okay. They brought in a full suite of regulations for not just London, but all of England in 1966, okay, and they stayed in place, and with some exceptions and increases on it. But then in 2017, in June, Grenfell Tower happened, and there were 72 fatalities. And coming out of that 5 years later, they've actually enacted a Building Safety Act, okay, and a lot more statutory instruments and guidance, okay. Grenfell Tower was a large, complicated building, and what we're really talking about here tonight are dwelling houses, and that's really the focus here, but it gives you just an idea of where regulations have come from. The other issue is that, you know, the regulations aren't just in Ireland and England, okay. If you go to any of the developed economies, whether it's in Europe, Canada, America, Australia, they all have regulations, and they all have the same type of regulations. On occasions, we'd look at actually the fire regulations in some of those jurisdictions that are quite similar. But it's not just within the developed world, okay? You take Kenya here, for an example. This is a World Bank report. Their process here: submit the application, issue the permit, construction inspections, and an assertive occupancy, okay? And you can see down here, okay, they actually have an e-platform, a BCMS equivalent in Nairobi, to allow people to go along and lodge documents and document inspections. So building regulations is part and parcel of kind of what's happening worldwide. In Ireland, I suppose we were slow in terms of bringing in regulations after the state was founded. We brought in planning permissions back in 1962, and then in 1990, the Building Control Act was enabled, okay. These are Irish regulations written and passed through Dáil Éireann, okay, for Irish people, right? So they're not being actually put together by somebody from the outside. Building control regulations, they cover the fire safety certificate, they've covered the commencement notice, disability access cert, and since 2014 then, the cert of compliance and completion for all buildings, with the exception of the opt-outs for dwelling houses and agricultural buildings. Building regulations are a set of expectations in terms of fire, structure, hygiene, access, and then there's technical guidance documents that are actually give details of what should happen on the ground in terms of buildings. The regulations, if you go back 400 or 500 years ago in London, they were very prescriptive. No thatched roofs, no wooden structures within the city of London, okay? That's now changed, okay? Not just in just jurisdiction, but right around the world. They tend to be performance-based. So you can now have a thatched roof in Ireland, okay? But it has to be 6 meters from the nearest building, all right? So the regulations are more performance-based. It's not simple black and white rules anymore. Why are we doing this? And Dave mentioned it as part of his introduction. In Ireland, we had historically 40 to 45 to 50 deaths a year. Okay, we're now down in the late teens, early 20s. Okay, and this is an example here of good construction. So you can see here, on the left hand side, the room is actually gutted because of the fire. Okay, it's a fire door. Okay, with a closer on it. The door on the far side here, you can see there's some smoke damage at the top of the door. Okay, but the door itself has actually stopped the fire from coming into the actual passageway, all right? And the door is not just a door leaf, it's the door ironmongery, the door hinges, okay? The door closer, and then also the frame on the door itself, okay? And how that's fitted into the wall, all right? And that's part of what we're going to talk here tonight. Building reaction or fire resistance, fire reaction, right? There's definitions here, okay? But what I'm going to do is go on to the next slide just to talk to it. And I suppose our concern would be, and not merely talking to people who are professionals in the construction sector, but actually maybe when we go out do licensing inspections in the hospitality sector, they tell us something is fire rated, okay? The reality is it either has to be fire resistant or have a reaction to fire. And just to explain kind of that actually a fire resistance is essentially the wall will either withstand the actual fire for a duration, stop the fire flames coming through or the smoke coming through, and stop the heat coming through. And then over here, then a reaction to fire is that if you light the fire lighter here at the bottom of the actual structure, if it's made of concrete, the fire won't go up along the structure. If it's polyurethane or PVC like it was inside in Grenfell Towers, the sad reality is the fire has traveled very, very fast. So a little bit more detail here, okay, in terms of the actual fire resistance, okay. It's not just fire resistance, there's actually a designation of resisting in terms of low bearing capacity, integrity, and insulation. So a low bearing capacity means that if the fire is here, the wall will stand for 30 minutes or 60 minutes and won't collapse. But it doesn't mean that the fire won't go through the wall. If it's got integrity as part of the designation for 30 minutes or 60 minutes, what it means is that the flames won't pass through the wall, or the hot gases or smoke won't pass through the wall, but you will still get some heat transmission through the wall itself. And the last one then is, okay, if it's got an insulation rating, okay, then the hot gases will be actually held back, the flames will be held back, and the heat will be held back. So on the far side of the wall here, you would be actually unaware the fire was actually happening because of the integrity, insulation, and resistance of the wall itself. In terms of reaction to fire, again, it's not just a simple, it's fire rated or it's got a fire reaction rating. A1 is over here, non-combustible, so it could be a plasterboard or it could be a concrete block, okay? And then over here, you've got polyurethane and polystyrene. And then all the way in between here, you can use in some circumstances, but again, the regulations tell you when you can use them, when you can't use them. So in terms of looking at the actual fire, particularly for dwelling houses, I want to step back and use a different analogy, all right? And you take here a Scania tractor unit that actually is bought from Scania, okay? That gets converted into a fire appliance, okay? And the way that runs essentially is that the tractor unit is purchased and it then goes to a bodybuilder who puts in the water tank, the lockers, the pump behind it, as well as putting in space for ladders on top, okay? If that's done in Ireland, it has to be built by an approved vehicle bodybuilder scheme. And that's governed by the NSAI, the National Standards Authority of Ireland, okay? And they've got a code of practice, okay, that's over here. And they have purchasing requirements, drawings, and control plans. And again, the detail is here on it, okay? And I suppose what I'd be suggesting to you essentially is that the construction sector is becoming more and more like an assembler of approved items rather than building from scratch. So the technical guidance documents, there's a lot of documentation out there, and we're very conscious of that within the actual sector. Within Ireland, we've got 12 guidance documents, A for structure, going down as far as M for disability, okay? We're going to talk about one of them here, which is actually technical guidance document B, volume 2, building regulations, technical guidance for dwelling houses. And the link is here if you want to take a look at it. So in terms of volume 2 for technical guidance document B, okay, if you follow the guidance in this document here, you've got prima facie compliance, you've got legal compliance with the actual building requirements. It's a bit like the seatbelt. If you put on your seatbelt, you're obeying the law. Again, if you follow the guidance here, you're obeying the law. And it's a minimum standard. So in other words, nothing precludes you from going higher than that. What's in the document, and these documents run to about 100 pages, so the 12 documents could be 1200 pages of guidance documents, okay? There's 5 sections, B6 to B10. B1 to B5 are for commercial buildings, so we're just talking about domestic dwellings here, so it covers B6 to B10. So B6 talks about there has to be fire detection now within buildings, okay? And there has to be means of escape, not just windows, but doors. The internal linings, you can't go along and have polyurethane as internal linings because it'll let out a fire spread very easily. And in terms of structure then, the structure has to have integrity in terms of standing. And then also if there's cavities in that structure, it has to make sure that cavities don't allow the fire to travel very easily. External fire spread, so detached roof, an example of that, that you have to be sure that what we're building, the actual dwelling, won't allow the fire spread rapidly to other dwellings. And finally then access to the fire brigade. On top of that then, there's actually what's called supplementary guidance, okay? So if all houses were built of stone construction like they were maybe in the 17th or 18th century, okay, then they were very fire resistant, okay? Today we're using a lot of timber framed and modular construction, okay? And this guidance here gives you supplementary guidance of how you should comply with the actual technical guidance document. And if you build in accordance with this requirement here, then you're in accordance with the European test methods. So all the guidance here has actually got detailed fire safety testing within test houses right across Europe before it was published. In terms of fire resistance, which is probably our primary concern here when we're looking at dwelling construction, there are probably 3 numbers that people need to be aware of, okay? The first one is REI 60. So what that means essentially is that there's a red line in the drawing, typically, okay? And that indicates there's 60-minute fire resistance for low bearing capacity, 60 minutes for integrity, and 60 minutes for insulation. 2 other designations you'll see are REI 3015, which is this designation here. So that means 30 minutes for resistance and integrity and 50 minutes for insulation. And then the blue line is actually 30 minutes for all 3 REI. So what does that look like? Okay, so you take here a 2-bedroomed semi-detached house, entry door here on this side, sitting room, kitchen, and a stairs up to the bedroom. You then have a party wall here, and then at the other side of the wall, again, another 2-bedroom dwelling, okay? There's a red line here down through the middle of it, indicating the party wall, indicating that it should be 60 minutes fire resistance for low bearing capacity, integrity, and insulation, okay? If that's built out of concrete, you get that as part of the deal, okay? If you're building out a frame construction, if you use this guidance document here, it tells you how to go and comply, so you get 60 minutes here. And I talk about the requirements if you step away from this document in a second. If you've got a dormer bungalow, okay, standalone, okay, then there also are requirements here. And you can see the dotted green line here means that actually you should have REI 3015. So that means that if the fire starts here in the kitchen, okay, the bedroom should be separated from the kitchen by fire resisting construction. That should stop the fire from transmitting in terms of the load, the floor falling down for 30 minutes. It should stop the heat and smoke transmitting into the bedroom for 30 minutes. And then for 15 minutes, okay, there should be actually no transmission of a warmer temperature and the floorboards up in the actual bedroom. And that allows people to get out. And you can see that requirement here is not just for the actual the floor between the kitchen and the bedroom, but also in terms of the actual structure of the attic and the structure of the other bedrooms or other living areas downstairs. So if we decide to step away from the ancillary guidance document frame construction, okay, or from concrete, okay, then you're looking at substantiation, okay. For concrete, it's very easy here. This is an extract from one of the actual vendor sites, okay. So you can see here that if you use a 4-inch block or 4.5-inch, 6-inch block, you get 1 hour or 2 hour rating, okay. And the key issue for a concrete construction would be the cavities, making sure there's fire stopping in the cavities, and then the openings, which Martin will talk to, that if you actually start opening up the actual walls or the floors, then that causes problems in terms of fire transmission. If you've got stud construction, okay, then you're into actually, if you step away from this guidance document here or ancillary guidance, then you're into looking for substantiation from the vendors, okay. This is a well-known vendor here, the White Book, okay. 30-minute fire resisting construction, 12.5 mm board, and then you can look at the substantiation here behind it in terms of the stud build-up. Posi joists, again, a lot more common within construction now because of all the ventilation and other ducting requirements that's happening in dwellings, okay. This table is a bit detailed, but just to kind of give you an overview of it, okay, it's the fire resistant tests that have been completed. You can see here on the left-hand side, they're all REI 30, so they're all getting 30 minutes across all 3 characteristics for fire resistance, okay. If you go over here to the right-hand side, you'll see that the actual tests have different times in them. So this test here was done at 55 minutes before it actually stopped without failure. This one achieved 36 minutes, and this achieved 42 minutes, okay. But the difference here is, okay, that the testing on the top line was done to BS 476. The testing in the bottom line was done to EN 1365. And the key issue essentially is that the new standard requires us to actually build dwelling house in accordance with EN standards, okay? The BS standards are only there for existing dwellings, okay? And if you look over here, then it gives you details in terms of joist centers and the joist steps, okay? And then the screw fixings, okay? And the report is over here. So there's a substantiation report that actually goes through here. This point here, I think I already made, okay, that the new dwellings are to Eurocodes, existing dwellings are to the old British standards, the 476 testing. So a test report, and again, this applies if you're stepping away from the supplementary guidance, okay? You've got to go along and look at the details. This is a test report that was done in a test house in the UK, right? It was done in accordance with the European standard 1365, okay? It was looking at a timber floor with downlighters, okay? With 15 mil slab, 225 mil joist at 600 centers, okay? With 22 mil tongue and groove chipboard above, okay? And then they put in 7 downlighters into it, okay? And I suppose the key issue here in terms of actually fire safety is that if you go along and put in a concrete floor, you can say you get 60 minutes. When you start putting in frame construction with downlighters, okay, the only way you can go along and improve that is by bringing it to a test house and showing that it actually works. So the test report here shows that it passed load bearing capacity at 31 minutes. It passed the integrity requirements at 31 minutes. And it passed the insulation requirements at 31 minutes. So the detail is there. The report runs to 25 pages. I've just taken a sample out of it. And this is the sign off on it, okay? And one of the key issues here is that you can't take a report in isolation. You need a full report, and the link is there. And you only need to go to this level of detail if you step away from the guidance that is provided in the supplementary guidance. So that concludes my kind of regulatory overview, okay? What I'm going to do now is hand you over to Martin Moore, my colleague, and he'll go through some of the actual on-site technical specifications. Martin?
Thanks, John. Yeah, so as John said, I'll share my screen with you here now, guys. Okay, perfect. So as John has kind of alluded to there, he's kind of gone through the regulatory pieces and the test information back and all this kind of stuff up. What I want to kind of get down to now is get into the nitty gritty of it and the technical advice with regards to the details, the junctions, the fire stop, and how all that kind of goes together. So what I would like to just do, if you have any questions as we go on, please use the chat function that we have here in Zoom, and ask us whatever questions you want, or if there's any specific ones you want, you can contact us afterwards as well. But anything we can't answer during the Zoom call, we'll come back to you with an answer on. So as Dave kind of alluded to at the start of the presentation, what we've been working on here is kind of a consolidated guidance document for technical guidance document B, volume 2, and for the supplementary guidance. So I can very much appreciate it, and John alluded to it as well, there's a substantial amount of guidance out there, and it's knowing where to kind of find it and where to go to you can get quite bogged down in it. So the idea behind this document was to effectively streamline it all. You will effectively just have to go to this document for the kind of most common types that we see in most common house types we kind of see in Tipperary, your bungalows, your dormer bungalows, your 2 stories, dormer 2 stories, and your 3 stories. And it will effectively kind of tell you what type of fire resistance you need, what kind of escape provisions you should be providing. Kind of the idea was to create something similar, almost like to the ACDs. I suppose, look, they're not exactly details, they're diagrams of the houses, but I think we all kind of think in that way. So it's quite a handy little fact sheet that you can hand off to either subcontractors or to other designers and kind of say, hey, this is my bungalow, right? These are the kind of the base level fire safety provisions that I need to be providing. So what you'll see is, take, for example, the bungalow dwelling. So obviously you've got a truss there that's not doing anything in terms of a means of escape or anything like that, or we're assuming it's not supporting the external walls in any way, so it doesn't require fire resistance, okay? You've got your external walls there. So in a bungalow situation, if you're more than 1 meter away from the boundary, REI 30, or sorry, RE 30, REI 15 is adequate. Now, what I will say, okay, and even when it comes to the supplementary guidance, is any of the scenarios or the wall types or truss types, floor types tested in the supplementary guidance, they're all achieve REI 30. So they've achieved the full 30 minutes fire resistance, okay? TGDB is I suppose, lacking in terms of RE 30, REI 15. There's not many manufacturers out there that are even going to provide you test certification for that. They're all going to aim for the higher value, purely based on the fact of the cost of the tests that are involved, you know. So majority of results and majority of build-ups out there will actually achieve the full REI 30, but it is always worth checking all the same. So if you are wondering what does achieve RE 30, REI 15, talk to the manufacturers, check out the Agomon certificates for the products that you're planning on using. As I said, these are not going to catch everything. These are effectively kind of, you know, they're the base level of fire safety. You need to still review 10 Guidance Document B Volume 2. You still do need to review the supplementary guidance, but this is just to kind of give you a very, very quick overview of when do I need cavity barriers, when do I need to look at the fire resistance external walls, items like that. Go on to our dormer bungalow. So again, you'll see there, and John alluded to it in his presentation, you've got your truss with a fire resistance in this scenario because the truss is acting as one unit. So it's effectively providing the floor of the first floor of the dwelling. So in that case, the entire truss needs to be fire resisting, not just the floor or the underside of the truss there. Because if the upper parts of the truss or any of the webs give way, theoretically it's going to compromise the floor structure. So the whole system has to be protected in that regard. But again, it's just giving you a rough idea again of kind of, you know, the maximum heights for windows for escape. That one there in terms of dormers is often one that's often missed. Is the 1.7 meters maximum from the eaves to the vertical plane of the window. And again, we're talking about, you know, what kind of protection to the stairs do I need in a 2-story dwelling or in a dormer bungalow? Really, all you need is that the stairs needs to be enclosed in story height construction, which need not be fire resisting. There are open plan arrangements, and again, I'm referring you back to section 1.3.2.1 of TGDB Volume 2 for guidance on that and where that can be used. So again, 2-story dwelling, very similar to the dormer bungalow. So this slide is probably one of the most important of all of the presentation, really. Okay, the devil is in the detail with everything you do in terms of fire safety. Okay, you could have 3 layers of plasterboard onto a timber frame wall, or you could have a blockwork wall that's a standard block on flat 215 millimeters thick, and happy days. But as soon as you start puncturing holes in that, or as soon as you start joining that with something else, or you start creating cavities in it, the devil is in the detail with this stuff, and those systems can completely fall apart very, very quickly, regardless of how thick they are or how dense they are, if the junctions aren't done right, if the fire stopping isn't done right, and if the cavity barriers aren't done right. So what I would say is it kind of needs to be communicated down to site. You need to maybe look at generating maybe generic details for junctions and fire stoppings and cavity barriers, especially even with regards to if you're specifying systems. So if you're specifying a timber frame house or a metal web structure, a lightweight metal web, metal frame structure, I should say, do not leave it off to the manufacturer. The manufacturer will develop stuff for the structure for you, but you are going to have some sort of bespoke details with regards to the junctions, with regards to the fire stopping, and in regards to cavity barriers. because the dwelling you're creating or the development you're creating, the house types, they are going to be specific. They're going to be unique in their own right, and they're going to have their own issues with regards to how junctions are going to fit. So with regards to junctions, you're looking at what kind of joint is it? How robust is it? What's the overlapping of my boards like? You know, it's all about the details. Fire stopping, we'll talk a little bit about expanding foams later on in the presentation, but you're now looking maybe at fire collars, pillars, stuff that the domestic side of the sector is not actually really used to. Is stuff that would have been commonplace on the commercial side for a number of years, since probably taking guys stock in 1997. We would have seen the fire collars on pipes and stuff like that. But now, as we become more kind of advanced in our construction methodology in the domestic market, we are now starting to see these type of systems and fire stopping actually being required even in the domestic side. The other thing then, in terms of cavity barriers, you have to look at what kind of the size of the cavity, what's the pipe, what enclosure is on the cavity. What kind of cavity barrier am I using, and probably most importantly, the fixing of that cavity barrier. You know, that it's going to actually perform and do its function if a fire does happen. So just to talk through maybe some very key critical junctions that again we're kind of seeing in terms of building control inspections that need to be kind of picked up on. So you take your party wall junction now, and I'm kind of talking more probably in framed construction here. So your lightweight metal frame or your timber frame developments or houses, whatever you're doing. Okay, the party wall is a critical junction in terms of the vertical separation between dwellings. Okay, what did come out when the supplementary guidance document was published with regards to timber frame dwellings, it did specify that party walls must now be constructed in the factory if it is a frame type system. If it's a block type system, no problem, there's no issue there. But if you've got a frame type construction, the party wall has to be constructed in the factory. The problem with that, though, is it still requires some sort of site works in terms of fire stopping and things like that. So if you look at that little diagram there in the bottom left-hand corner, I want you to kind of consider how the panels are going to be assembled, okay? Don't leave it to the erectors on site, because the timber frame guys are thinking about how do I get this thing up and how do I get it structurally sound. They are going to still require a bit of guidance, and you're going to have to step in as your role as designers and builders to make sure that the junctions still all work, how it all goes together. So what we'll often see is you might take the attic panels there. You might have two spandrel panels connected together in the attic, providing your fire resistance across the party wall line. How does that joint get fire stopped? Because effectively you've got lovely double lapped fire line boards on all the panels coming from the factory. But when they are butt jointed to something like the rear annex in a dwelling, or as I said, those two attic spandrel panels, it's fine at the floor levels because the floor joists are going to block off the joint. But it's where you have those vertical joints or any horizontal joints outside of that have to be thought about. An additional fire stopping might need to be required, whether it be additional boards on, or we cut it back and we put in a slip of board to overlap the joints and make sure everything is tidied away that way. So it's about kind of thinking outside the box a small bit and just thinking beyond just offloading it to the frame to the manufacturer of the timber frame or the lightweight metal frame. That picture there on the top right was an interesting one. Then again, as I said, thinking about the details. It's a little bit difficult to see in the image, but effectively what happened there is we carried out a building control inspection on a development of timber frame houses. And again, it was brilliant. The party walls had all been manufactured in the factory. But what the manufacturer had actually done was he had left a gap at the bottom of all the party wall lines to allow the sole plate or the bottom plate of the timber frame to be nailed onto the sole plate. But that effectively left then a 25 mil gap within the actual fire resisting there, because the floor covering was just going straight over that. So you had a significant gap there where a fire is going to break through, and that wall is not going to achieve it's required 60 minutes fire resistance. So it's about just thinking about that and having the awareness of those junctions. Another big aspect then obviously is our roof truss fire resistance that hasn't really been thought about up to maybe I suppose the last 2 years when it was added to the supplementary guidance document. So because a roof truss is acting in uniform, it's acting as one unit, and the timber members are so small, you have to consider providing fire resistance to the entire truss where it's required. So what I've kind of noticed is there's probably 4 typical scenarios where fire resistance is required to a truss. Okay, sorry, it's going to be required where you have a protected stairs, let's say in a 3-story house, and you have the stairs going up and it's interacting with the roof. So you're either providing a fire resistant ceiling throughout the entire upper floor, or you're looking at how the stairs goes up and does it connect onto the sloping part of the roof, and then you fire resist the truss to suit that. Or if you've got a dormer roof truss, like in the image there on the left hand side, Again, the floor of that truss is the bottom of that truss is performing the requirements of a floor. So the entire truss has to be fire resistant to ensure it's okay. If you've got a roof that serves as an escape route, so again, if you're escaping across a roof, that's when it also needs to provide fire resistance. Or again, very importantly, when it comes to modular construction, your timber frames, your metal, lightweight metal frame construction, if the roof is providing some sort of structural resistance or some sort of structural lateral stability to the external walls, and if that roof collapses, if that takes down the external walls and they're required to be fire resisting, then the entire roof truss should be provided with the same equivalent level of fire resistance as those external walls. So you see there are just two extracts from the supplementary guidance. They're broken down into a 47 mil wide truss and a 35 mil wide truss. And again, depending on the width of the truss, it's going to determine the level of fixings and the depth of the fixings and the security of the fixings in it. What you're looking at most of the time, guys, is probably a 15 mil, at the very minimum, 15 mil wall type A board, but in most cases, it's probably even a type F plasterboard. So again, as I said earlier, the supplementary guidance, any examples given in that, they're all tested to the full requirements of REI 30. And again, it depends on the different build-ups based on the joist's width. So moving on then to protected stairs. So what you have to consider with protected stairs is the significance of the enclosure, and it's about looking at all these details of, even if it's whether it's a non-load bearing wall or a load bearing wall, how the plasterboard is taken up and joins in with the wall, with the wall structure from the ceiling to the wall, that you have a continuous line there, and that there is no gaps, there is nowhere for a fire to penetrate through from the fire side of the room into the stairs. So what you have is your two options: is you bring up your cavity barrier, obviously in the roof space, to close off the roof space from above the protected stairs, or you provide a fire resistant ceiling throughout the entire upper floor. But what you have to really consider is, if you're providing a fire resistant ceiling, every opening through that ceiling then has to be fire stopped. So any spotlights, any downlighters, mechanical ventilation systems, anything like that, soil vent pipes or ventilation pipes, anything at all, if it goes through that plasterboard, it has to be fire stopped to maintain the integrity of the protected stairs. So again, the other aspect then of TGDB Volume 2 that it's going to call upon is the requirement of FD20 doors to your protected stairs, and I'll talk about the requirement for fire doors in dwellings a little bit further on. Well, there was a myth out there at one stage that because it was a fire door in a dwelling, it didn't need a self-closer. It needs a self-closer, and when you're looking at a fire door, it's the full assembly. It's not just the panel, okay? So just be kind of mindful of that. Again, sockets there on the right-hand side, I'll talk about them a little bit further on in terms of their impact on the fire resistance of walls. So fire doors. So what you have called up in Technical Guidance Document B is FD20 and FD30S doors. So FD20 to the enclosure of protected stairs, and FD30S then between the dwelling and any attached garage. So you're going to struggle to find an FD20 door. They've kind of been phased out by the industry. The idea behind the FD20 doors was it was kind of, the main difference really, I suppose, between FD20 and FD30 is the intromission seals. In the majority of FD20 doors, you didn't need the intromission seals, so you're completely reliant on the gap between the door panel and the door frame being as minimal as possible. Because of site tolerances and things like that, that's very difficult to achieve. So because of that, the industry has kind of just moved on to just providing FD30 doors. The problem is, though, is with regards to, if you go onto any kind of builders merchants websites or anything like that, like the extract I have there, they are just selling you the panel. But you should always request kind of supporting documentation on that with regards to the test certs. Because the problem is, if you have a client that wants to put a particular set of ironmongery onto a fire door, that ironmongery might not have been tested with that door panel in a particular type of frame, in which case you've now compromised the entire door, and it doesn't matter the fact that they're calling it up there as an internal half-hour fire check door. If it's not done in accordance with the test certificate, you're kind of exposing yourself. So it's just to be kind of aware of that a fire door, it's not, it's an assembly, it's a door set. So it must have certification demonstrating it's tested as such. You can't just have a panel and say the panel is a fire door. Everything works together: the closer, the hinges, the ironmongery. So what you'll find with 30mm fire doors, there's at least 44mm thick. The softwood frames are fine. You'll have 3 fire rated hinges, and the door closer again has to be included. Just to be aware again for yourselves, BS 8214 is the code of practice for fire door assemblies. Very, very good guidance document to go through and be kind of familiar with for your own knowledge. So this is just kind of an extract from test documentation on fire doors. So you see from that the actual detail, this is the level of detail that these test documents actually go down into, in terms of they'll have a number of different frame types, a number of different locks and latches, hinges, door closers, for all the ironmongery and different furniture for the door in terms of glass and everything, will all be detailed in that test documentation. So what you need to be very, very aware of is, am I lining up? Does my door handle and my hinges line up with the panel that I've selected and with the frame that I have? And if all that lines up together, then you can 100% stand over and say this fire door is in accordance with this test certification and you've done your job correctly. So I want to just show you a very, very quick video. And again, it's something we break out in terms of our community fire safety talks and stuff like this. And it's just more about even the importance of closed doors. So a lot of people tend to disable self-closers and things like that. If the door isn't closed, it's not performing its function. It's not doing its job. So even just something as simple as a door here in this scenario in a domestic setting, this is a video that we put up on our Facebook page a couple of years back. It was a house fire that our Clonmel Brigade had attended. But I just want to show, just talk you through the video. So you see there, that's the fire side of the door. I think it was a door between a kitchen and a garage or something like that. So completely charred, completely destroyed. And this is just a standard panel door, nothing special about this, not a fire door or anything like that. And there's the accommodation side of the opposite side of the door. Because the door was closed, it gave the occupants a chance to get out, and had a significant impact on the escape provisions in the dwelling. So it's important just to be aware of that. Now, just to move on. So again, and John alluded to this in terms of the metal web floors or the posi joists that have become hugely popular in recent years because of the amount of ventilation systems and downlighters and services that were passing through floors over the previous generations there, where you had the solid joists. So what you see there on the left hand side is actually a test assembly for the metal web floors. Okay, and what you see is every single downlighter has a hood, and every one of the diffusers for the ventilation system all has a damper there, as shown there on the right hand side, or it has a fire collar on it. Okay, and that's the level of fire stopping that's required with these floors. The problem is, if you provide only a 12.5 mil, a 12.5 line fire line board will not achieve a 30-minute fire resistance on these floors. The metal web melts at very, very low temperatures in a typical house fire, and you get an image like what's up there above, where it's just basically the timber top cord and bottom cord. That's all that's left. So it's just about being very, very aware that you need at least a 15 mil type A board, or type F board, but a type A as a minimum. A 12.5 mil type F board will not achieve the required standards under the EN test standards 1365. So just to be very, very aware of that, 15 mil type A, and every opening through that board has to be fire stopped. The entire system, or the entire floor, is dependent on that plasterboard layer and the fixings going through that into the joist to provide that structural protection in a fire scenario. So socket outlets, again, are kind of a big gap I kind of find in the knowledge in technical guidance document B, and even in the supplementary guidance, they're not really, I feel, kind of explained very well. It kind of just says that all sockets and stuff like that should be fire stopped. So we've done a little bit more digging on this, and I've gotten feedback from the department on this as well. So sockets, with regards to kind of framed construction, what you're looking at is separating them out in between stud voids. So we should not have back-to-back sockets where we require either 30 minutes full fire resistance or RE30, REI15. What you want to do is separate them out, each socket in each stud void, whether it be metal frame or timber frame, and you cannot have anything bigger than a double socket in the one void. Okay, if you have anything bigger than that, then you're into looking at fire stopping the actual the socket itself, like with the fire putties you're seeing there in the bottom left hand side of the screen. The other side, just to be very, very aware of, is it has to be a metal backed socket. Plastic back sockets are not accepted, and they haven't been tested. So what has been tested is metal back sockets, and the socket is in its own individual stud void within the build-up. If you can do that, then you will achieve the required fire resistance of REI30 or RE30, REI15. Just to be aware, again, another very good document out there is BS 8313. It talks about kind of the accommodation of building services and ducts and stuff like that. But what it actually specifically says is that a risk assessment should be conducted where you're putting services into a fire or into a wall that requires fire resistance. So just something to kind of be aware of. But the biggest thing there really is avoid back-to-back sockets in the same void, and make sure that if you're going with more than one socket or anything like that in the same void, that they then need to be fire stopped. So as I said, there's a perfect example of the devil not being in the detail really in this one, or being in the detail in this one, depending on what way you look at it. this was a protected stairs that had back-to-back sockets in the same stud void, and it broke through from the living room straight into the stairs and compromised the whole thing. So you can see that lovely little fire door there in the background. Didn't even get a chance to perform its duty because the wall on the opposite side of the room, or on the opposite side of the stairs, failed based on sockets being in the same stud void. Just something to be very, very aware of then with regards to kind of fire stopping limitations. There's kind of a bad job being done in terms of advertising fire stopping foams and fire rated foams and all this kind of stuff. So that's just a little extract there from a fire rated expanding foam. So it's saying that it'll achieve 120 minutes of fire resistance. It is tested, which is great, fantastic. It has approval, it has all the certificates, but just because of that, it does not mean that it's going to be suitable for every single void that you come across that needs to be fire stopped. So that might be fine for a 10 or 15 mil gap around a door frame, between the door frame and a concrete wall or a concrete block wall or something like that. But it's not going to seal up, or it's not going to perform to the same level if you're trying to seal up a 200 mil cord oak or something like that with that product. You're into more significant forms of fire stopping in that regard then, whether it be cement and lime mortar, or you're looking maybe at a mineral wool, a reinforced mineral wool, an intermittent paint or something like that. So just be very, very aware of that in terms of what's suitable for what voids. So what you'll see just on the next slide then is you take account there, like that was a very bad example there on the left-hand side of absolutely no fire stopping whatsoever. It looks like he tried to put his boot through the block wall to put in the cabling. Similarly there with the pipe work going up through a concrete floor, and that's in that scenario should have been a collar put on that. There is a fantastic document brought out very recently after the whole Grenfell disaster in the UK called the Fire Stopping of Service Penetrations, Best Practice in Design and Installation. So it was a collaborative approach by a number of different institutions in the UK that actually it's a very, very good kind of accessible document with regards to for builders and for designers to show them what kind of fire stopping is required in what situations and what product is probably best suited to depending on the oak size and the cable trays or whatever the size of the pipe work or the cables going through it are, and how best to do it. So again, I'd recommend anyone just to give that a Google. It's free to download. There's no requirement to be subscribed to NSAI or anything like that. To talk very briefly then about cavity barriers. Again, there was significant changes in Technical Guidance Document B Volume 2 with regards to cavity barriers over the original guidance document that we would have used with regards to TGB 2006. So what happened in Volume 2 2017 was diagram 17. If you remember that diagram from TGB 2006, that was actually taken out of Technical Guidance Document B Volume 2, and I have a feeling it'll probably be taken out of the next iteration of the Technical Guidance Document B for the commercial side of the house. But effectively now what they've said is instead of a cavity being diagram 17 compliant, what you now need to do is provide a cavity at the top of all external cavity walls. Doesn't matter if it's masonry or frame construction, and that includes any gable wall. So if you look at that top left image there, you have to provide some sort of cavity closer at the top. Now that needs to be balanced obviously with Technical Guidance Document L, because we can't have a block on flat bridging across the cavity or a fiber cement slate that's going to bridge across the cavity and create a cold bridge that's going to cause mold and dampness on the inside. So what you're looking at is kind of proprietary systems to close off the top of the cavity in masonry construction. And I think again, it's probably not gotten onto sites as quick as it should have, but it's just something again just to be aware of as designers and builders, that there is a requirement there to close off. So if a fire breaks into a cavity, because let's be honest, the PVC window is going to melt relatively quickly in a fire scenario. So that fire is going to get into the cavity, and if there's no stopping between the wall cavity and the roof space, it's going to rapidly get into the roof space, and it's going to become a very, very enveloped house fire quickly in that scenario. So it's just something to be aware of. So you have obviously, so with regards to cavity barriers, then as I said, you need it at the top of all external cavity walls, you need it vertically at the junction of separating walls, and any such wall with, as an external cavity wall, above the enclosures to a protected stairs, and then around all openings in framed construction. So if you've got your timber frames, your modular construction, like your lightweight metal frames, you have to have cavity barriers around all the windows, all the doors, any of the vents coming out, or any service boxes, ESB, telecoms, anything like that has to be provided, similar to that middle picture there where it's showing the red Rockwool sock kind of provided around the window and tacked back onto it. And again, it's about thinking about those fixings back onto the structure of providing this in place. It shouldn't be loosely fitted. It should be friction fitted and then also secured in place as well. Okay. So what you need is either 0.5 mil of steel 38 mil of timber, or your proprietary cavity closure systems to get you the 30 minutes fire resistance that's required by cavity closers. Now, something that's propped up a few times now, and again, I've been looking for kind of clarification from manufacturers on this regards to insulation. There's a kind of a misconception out there that because you are providing full fill insulation in the cavity, that you do not need cavity barriers to close off the top of the cavity. If you actually go to the Agremont certificates of any of these products, whether it be the board insulations or the pumped bead insulations, what they will say is that cavity barriers should be installed in new buildings in accordance with Part B Volume 2 Clause 3.6. And that's what I just read from a few minutes ago in regards to closing off that cavity at the top. If it's a masonry cavity wall that you need to have a cavity closer at the top of that to ensure fire does not break through from the cavity into the roof space. Now, there is an argument that they do try and provide to say that, look, if a fire does break into an unventilated cavity, that the amount of air is going to be insufficient to support combustion and flame spread. The problem is, especially with the beads, any of the EPS boards are highly flammable and highly combustible. So fire will track very, very quickly in there, especially if a window falls out. As I said, PVC is going to melt at low levels. It then has free reign into the cavity. That bead is going to catch fire and she's going to track up. There is no test data to say that an unventilated cavity will not support combustion. It's just kind of a spiel that they have in it. But at the same time, as I said, the Agremont cert then is kind of saying, by the same manufacturers, is saying that they should have cavity barriers or fire breaks in accordance with section 3.6 of Technical Guidance Document B Volume 2. So as I said, just be very wary of that and cover yourselves on it. Some key details then in regards to kind of cavity barriers, and again, it goes back to, as I said before, if you're getting a timber frame manufacturer or a metal web or lightweight metal frame manufacturer on board, do not assume that everything is going to be completely fixed and sorted in the factory. There are still going to be site details that need to be kind of fixed and sorted out. So if you look at the left-hand image there, it's a cavity barrier that was brought across and then stopped because of the support structure on a corner window within a timber frame house. So that cavity barrier needs to run the entire way across, because as I said again, if the window fails, which it will do in a fire scenario, the PVC is going to melt at a very low temperature. A fire is then going to has free reign into that cavity and can cause issues. Or even there on the right-hand side, what happened there was they actually cored the background vents afterwards on site. So because they had done that and they actually had the blockwork walls erected at this stage, they didn't have a cavity barrier provided, basically, where the ventilation opening was going right through the cavity. So the solution that was come up with there was to actually take out the plastic pipe that they were sleeving it with and actually put in a 0.5 mil steel pipe instead. As I said, 0.5 mil would get you that 30 minutes fire resistance required for the cavity. So it closes it off, makes it nice and tidy as well. So finally, what I just want to talk about is fixings. So again, as I said, just as important as it is to look at the devil in the detail with regards to junctions and fire stopping and cavity barriers, fixings are something that need to be very, very taken seriously with regards to how many of them they are, what their spacing is, what screw length it is. We can't just assume that we can go into the builders providers and say, throw me out in a box of drywall wall screws there and we'll bang it together. It has to be a very, very particular screw length. So what the supplementary guidance document has at the very, very last page of it is a fixings kind of table, and it will tell you based on the wall types that were tested exactly what type of screw length was used and what the centers or what the maximum centers were for the perimeter and the internal lines or fixings of those boards. So again, something to be very, very aware of, and even just from yourself going doing your kind of your inspections on site, you'll see yourselves whether the board looks like they're kind of been a bit mean with the fixings, or have they actually put in enough as per for that. So they're like, you know, for the walls there, you're looking at 200 to 300 mil max centers for the boards. But when you get up to like the floors and the trusses, because they're on the horizontal and because a flame is going to impact them more, the fixings are at 150 mil centers, and that has to be put in. And again, sometimes you might even need longer fixings. So it's typically either 42 mil or 55 mil up to 60 mil. So just something again to be very, very aware of, that again, you could have 15 mil fire line board and it'll do everything for you, but if it's not fixed right into the timber, into solid grounding, it's not gonna work. We have to look, as John said, everything is a system now. Everything works as a system. We can't look at things in isolation, that a plasterboard on its own is going to give me the fire resistance. It's the plasterboard, it's backing what is backed onto, what the screw length is, and how those screws are fixed and what centers they are. So look, I appreciate that was kind of a quick kind of whistle stop tour kind of into the finer details of certain aspects of fire provisions and dwellings. For anyone who isn't aware, the National Building Control Office are actually running a full day Part B dwellings. They're copying us basically, but they're actually running it for an entire full day next week on the 24th of November. So if you go onto the Eventbrite page, or even if you Google NBCO Eventbrite, you will find a link to it. As far as I know, I think it's a free event. And I think as far as I know as well, for consultants or builders or anything like that, you can just join by Zoom. I think the venue, the Horse and Jockey, is just for building control officers and fire officers, as far as I'm aware. But well worthwhile going along. They'll be getting into much more detail than what we've tried to cover here in an hour, because I appreciate we don't want to keep you here all night. But if we have any questions or anything like that, we're more than happy, myself and John, there to take any questions or anything like that. Is anything kind of come through on the chat?
No, the chat, there was a question there on the availability of the slides. So we will share the slides alongside the YouTube recording of this on the website. Yeah. And, you know, as Martin said, this is not meant to be an education center, an educational session. It's more an awareness session. Yeah. That actually we want to raise awareness. And, you know, as we meet you outside in sites, you know, we absolutely mean what we said at the start. We want to work in partnership with yourselves, and we all have the same interest. Nobody wants to go along and have a building that actually is substandard versus the regulations, and the regulations are there for life safety. Like, you know, unless people have questions, like, we bring it to a close. And again, thank you very much for taking an hour out of your evening. And we're very much aware kind of the demands that are out there in the construction sector, given the level of change, the level of complexity. And we are at the end of the email or the end of the phone to answer questions and support you in your drive for excellence and prosperity.
Yeah, as John said, guys, think of us as a resource, not a hurdle to try and overcome. If you have questions, if you need a bit of guidance on a particular product, whether it be suitable for what it needs to be used for, because again, everything comes back to regulation Part D with regards to workmanship and the suitability of products, construction product regulations with regards to what it is. And as the construction sector gets busier and busier, more and more products start getting flooded onto the market. They might not be CE marked, they might not have test data. And it's just to have that kind of awareness and that kind of critical thinking to kind of realize, right, should I actually be using this product, or should we be looking at something else? And even if you are using a system and a certified system, it has to be used in its correct purpose, and you need to be kind of aware of any limitations on it. As I said, timber frame, modular construction, it's all fantastic. It's great to see it coming along, and we want to encourage kind of entrepreneurship in that regard, and encourage innovation and development. But at the same time, there still needs to be thought process put into how do these things fit together on site. How do we look at the junctions, the fire stop, and the cavity barriers? All those very, very important interactions that need to be considered. But as John said, look, we're here. If you have any specific projects or anything that you're working on, drop us a line. We're more than happy to help.
Okay.
All right.
So,
perfect.
Guys, we said we keep you to an hour. If you've no questions, we'll sign off, and thank you very much for your attendance.
Perfect. Thanks very much, guys. See you again.